Okay, so last time we have discussed uh, terms related to test of hypothesis, and we have also discussed the test of hypothesis for binomial distributions. Now today we are going to be discuss test of significance for single proportions for a large sample. Okay, so first of all, we start with the working rules. So let small p be the sample proportion in large random sample of size n drawn from a populations having proportion n. So here capital P which denote a proportion for a populations and small p which denote a sample proportions. Okay. And so population proportions has specified value p0. So you have given some specified value for a population proportions. So first thing we do, we set a null hypothesis. Okay, H0 as p equal to p0. That is, population's proportion p has specified value p0. After setting a null hypothesis, we set a complementary hypothesis, alternative hypothesis. It means p not equal to p0, or p greater than p0, or p less than p0. So alternative hypothesis might be two-tail hypothesis or one-tail hypothesis. In one tail, it might be possible right-tail hypothesis or left-tail hypothesis. Okay. Once we set the hypothesis, now we have to write the level of significance. It might be possible in some time you have given not given a level of significance in example. Then by default we consider it a 5% level of significance. It means 0.05. So mainly we discuss the example for a level of significance 1% or 5%. Okay, and test statistic. Okay, now here we have to test statistic. We have to calculate this Z. Okay, see here you have given a normal distributions. Okay, for large sample test. So we have to calculate Z by using this formula small p minus capital P upon under root pq by n, and where q is nothing but 1 minus p. Okay, so once we calculate this z, now we have to compare this z with z alpha, and z alpha which we get from the table. Okay, as we have already seen you in previous session. So find the critical value of z alpha of z at the given level of significance. It might be 1% or 5%, and according to which is a two-tail test or one-tail test, you get the value of z alpha. Okay, for 1% or 5% level of significance. Once you get the value of z alpha, now you have to compare with z. So mod z, if mod z less than z alpha, then the for level of significance alpha, and alpha might be 0.05 or 0.01. Okay, the null hypothesis is accepted. So whenever you get the test statistic z mod z which is less than z alpha, then our null hypothesis is accepted. And if mod z greater than z alpha at the level of significance alpha, then the null hypothesis is rejected. Okay. Now here, first note, null hypothesis S0 is rejected whenever mod z greater than 3 without any mentioning level of significance. If mod z, if you get greater than 3, then null hypothesis is always rejected. And confidence limit, in 5% of confidence limit, we have small p plus or minus 1.96 under root pq, capital PQ upon small n. And for 99% of confidence limit, small p plus or minus 2.58 under root capital PQ by n. So sometimes it might be possible you have to ask whether the confidence limit is applicable for a large sample test or not. So if you get greater than 99%, then null hypothesis is accepted. And Am I audible? Hello? Okay. So it might be possible sometime you don't have given capital P and capital Q. Then to find out the confidence limit for the 9%, 95%, you can use small p and small q. Whenever you have given capital P and capital Q in example, and if you say that find out the confidence limit up to 95%, then you have to use small p and small q. And for a 99% confidence limit, we have a formula small p plus or minus 2.58 under root pq by n. Okay. So whenever capital P and Q are not known, we use small p and q are used in equation. Now, example, in manufacturer claim that at least 95% of equipment which is supplied to a factory conform to a specification, and examinations of a sample of 200 species of equipment revealed that 18 are faulty. Test his claim at 5% level of significance. So here manufacturing claimed 95% of equipment which he supplied to a factory conform a specification. So 95%, uh, it means its proportions is 0.95, and sample we have given of 200, so which is n greater than 30. Here 200 means we have to use a large sample test, and n we have given 200, and out of 200, 18 are faulty. 18 are faulty, so we can find out small p, 18 upon 200, which we get a sample proportions. Okay, so first of all, n is equal to 200 in number of pieces conform to specifications. Okay, so which is 200 minus 80, 18 which are faulty, others are which conform a specification. So 200 minus 80, 182 out of 200, 182 which is conform a specification. So small p we can find out by 182 upon 200, in which I get 0.91. Okay, for the sample I get 91% equipment which conform a specification. And capital P we have given a population proportions, okay, which we have discussed in general. Manufacturer claim for all its product that 95% of equipment with which he supplied from factory which conform to a specification. So capital P here 95%, it means 0.95. Now capital Q, it means 1 minus capital P, and 1 minus 0.95. Okay, so I get 0.05. Capital Q is more 0.05. Now we have to set a null hypothesis. And null hypothesis is here P is equal to 0.95. This 0.95 is your point P0. Okay, so P equal to P0 as we have discussed in working group. P equal to 0.95. The proportion of species conforming to a proportions is 95%. Okay. Now once we set the null hypothesis, what we can say about alternative hypothesis? That it might be less than 95. Okay, if see manufacturer claim 95%, it means out of 100, 95 of its product which conform a specification. So alternative hypothesis, it means if less than 95 product which not conform specifications, then which is it means manufacturer claim is not uh, uh, which is not a right claim. Okay, so here for alternative hypothesis, it means or capital P less than 0.95. If greater than 95, then it is automatically satisfy 95%. Even we get more than 95. So here P less than 0.95 is our alternative hypothesis. If we get point less than 95, uh, uh, it means for less than 95% product which is not conformed to a specification, then we can say that which not satisfy our null hypothesis. So alternative hypothesis is always a complementary of null hypothesis. And here p less than 0.95. So our test is left tail test. Now level of significance, which we have already given in example. If we haven't given, then we have to by default consider 5%. Here we are discussing the claim for level of significance for a 5%. So it means alpha is equal to 0.05. Test statistics, and we have a formula for that. Z is equal to small p minus capital P upon under root capital P q upon n. And we have already find out this n small p and capital Q. So we can put this value in this formula, and what I get minus 2.59. So now we are going to find out mod z. Mod z is equal to 2.59. Okay, and then critical value which we get from the table, absolute value of z.05, which is 1.645. And I have already shown this table in last session that you have to remember this for two tail test, one tail test, okay, right tail or left tail, for 1% of significance and 5% of significance. So this value you have to remember. Okay, so here for this z uh, at 0.05 for a left tail test, you get the value is 1.645. Now you have to compare this value with mod z. So you can easily see that this mod z, which is greater than absolute value of z at 0.05. So what it means, if this mod z greater than 0, it means our null hypothesis is rejected. And so at 5% of level of significance, so we can say that the manufacturer claim is rejected. Is it clear for everyone? So what we have to do, we have start with the sample n equal to 200, and from that we get, this is for a large sample. Now then we have a number of confirmed spaces which we get from the here, that 18 are faulty, so 182. And once we get this 182 which confirm a space out of 200, so we can find out small p, and capital P we have already given 95%. And so once we get capital P, we can find out capital Q, and then we have set the null hypothesis equal to P0 as 95. And if out of 100, less than 95 item which not confirm specification, it means the null hypothesis is rejected. So the complementary hypothesis which I get here, P. Yeah, I'm repeating right now. This alternative hypothesis P less than 0.95. The question is that in question you have given that a manufacturer claim for its product that 95% of its product which conform a specification, whatever specifications the manufacturer has decided, which conform by 95%. So whenever you are given in percentage, it means you have given a proportion. Okay, and now we have take the sample. It actually manufacture, it means factory product, large number of products, but out of them we have taken a sample of 200, and out of 200, 18s are faulty. 18s are faulty. Okay, so first of all, sample of n equal to 200, which is greater than 30, it means we are discussing for large sample, and here n equal to 200. Now in working rule we have already discussed that we have to do all these steps: null hypothesis, alternative hypothesis, level of significance, test of significance, critical value, and decision. So for that, first of all, to calculate this statistic, we require this small p, P, capital Q. Now small p, which is for a sample, okay, and sample proportion, and sample proportions we get from like this, as we have know that out of 218 are faulty, it means 182 product which conform a specification, those are a good product, okay, as per the manufacturer claim. So 182 out of 200 which we get a conform specification, as we have taken here sample for 200. Now this 182 by 200, which give us a sample proportion. So sample proportions which I get 0.91, and capital P, which we have already given for as 95%, as manufacturer already claimed for each product of factory, out of 100, 95 which uh, pieces conform to a specification. So already capital P is 0.95, and capital Q 1 minus capital P, so which I get as 0.05. Once we have calculated this, now we have to set null hypothesis. And in working rule, we have already discussed P is equal to P0, and P0 we have given 95%. It means 0.95. That is the proportion of spaces conform to a proportion is 95%. This is our null hypothesis, which we have set. We are claiming that. Okay. And now alternative hypothesis is a complementary to a null hypothesis. Okay. Complementary to null hypothesis, it means now if null hypothesis rejected, it means alternative hypothesis accepted. And when null hypothesis is rejected, if point this proportions which is less than 0.95, okay, it means uh, whatever manufacturer claim 95%, if less than 95% we get, then we can say that manufacturer claim is rejected. That's why we have set here alternative hypothesis P less than 0.95. Now level of significance, which we have already given in example, 5%. Okay, so here this alpha is equal to 0.05, and now we have to calculate this test statistics. For that we have formula Z equal to small p minus capital P upon under root capital PQ by N, and we have put all this value which we have calculated here. We have already calculated this small p capital P we have given, and from capital P we get capital Q, and N we have already given. So we have put all this value, and what we get, Z is equal to minus 2.59. So first we have find out mod Z, and we have find out absolute value of Z 0.05, and this value which we have already shown in table. Okay, I show you this right now. Okay, uh, I have already shown you this table. See, uh, see this table. You can see that here for 1% and 5%. I already tell you that this value you have to be required to be remembered. This mod Z alpha for 1% 2.58 for two tail. Now here we have left tail, and we are discussing for 5%. So Z alpha is minus 1.65. But what we have do, we have taken absolute value. So absolute value is here, absolute value which we have 1.645. Now we have to compare these two values, absolute value of Z and absolute value of Z at 0.05. If this mod Z, which is greater than absolute value of Z at 0.05, then our null hypothesis is rejected. And if this is less than, then we can say our null hypothesis is accepted. Okay, and at level of 5% of significance. So here we get mod Z greater than absolute value of Z 0.05. So we can say that this manufacturer claim is rejected. Whatever he said that his 95% equipment which are confirm the specification is not correct. Might be less than 95%. Is it clear? Parth? Okay. So now we move for the next example. Here, the second example, in a study designed to investigate whether certain detonators used with explosive in a coal mining meet the requirement that at least 90% will ignite the explosive when charged. Okay, so 90% will ignite whatever detonator used in explosive. Out of them, 90% will ignite the explosive when charged, and it is found that 174 out of 200 detonator functions properly. So we have given sample of 200, in which out of 172 detonator which functions properly. It means will ignite explosive when charged. Okay, now test the null hypothesis p equal to zero point 0.9 against the alternative hypothesis p less than zero point 0.9 at the level. So in example, we have already given this null hypothesis and alternative hypothesis. And here we also said that which is 90%. So all mining requirement with at least 90%. So populations parameter we have given zero point 0.9. Okay, and n we have given 200 here. And small p we can find out, as we have already said, that out of 200 174 functions properly. So small p we can find out 174 upon 200, which is 0.87. Now capital P, which we have already given 90%, it means 0.9. Capital Q 1 minus capital Q is equal to 1 minus capital P, so zero point 0.1. Now null hypothesis, which we have already given, capital P is equal to zero point 0.9, and alternative hypothesis H1 means P less than zero point 0.9. So here P we have zero point 0.9. If less than 0.9, it means at less than 90% explode detonator which not ignite, then we can say that this our claim is not his claim is rejected. It means null hypothesis is not satisfied. So alternative hypothesis, which is always complementary to a null hypothesis. So here if we get p less than zero point 0.9, then we can say that null hypothesis is not satisfied. So whenever null hypothesis is rejected, it means alternative hypothesis is accepted. So here our alternative hypothesis p less than zero point 0.9. Now level of significance alpha is equal to 0.05. Okay, and test statistic small p minus capital P upon under root capital P Q by n. Okay, and small p we have given 0.87. We have already find out capital P 0.9, capital Q 0.1, and n is equal to 200. So by using this, we can find out test statistics. Z is equal to small p minus capital P upon under root capital P Q by n, and once we put this value, you get Z is equal to minus 1.41. So first of all, what we do, we find out mod Z, and mod Z is 1.41. And now this critical value, as we know that for lateral test, it for a as 5% level of significance, which is 1.645. Now you have to compare this mod Z and mod Z.05. So mod Z, which is less than 1 point, mod Z point at 0.05. So what we can say? We can say that this null hypothesis is accepted. Okay, at 5% level of significance. Is it clear? Okay, is it clear for everyone? Parth? Okay, so now we move for the next example. Yeah, now see the fatality rate of COVID-19 patients is believed to be a 15%. It means out of 100 patients of COVID-19, 15 patients are going to be dead. Okay, so in current year, 4,000 patients suffering from COVID-19 in Baroda city were treated in a private hospital, and 550%, 540 patients died. So out of 4,000, 540 patients died in some private hospital of Baroda city. Okay, and overall we have that overall populations that out of 100, 15 dead. So we have a sample given n is equal to 4,000, and out of 4,000, 540 people per patient died in a private hospital in Baroda city. Now, can you consider the hospital efficient at 1% level of significance? So, first of all, what we have given, small n is equal to 4000, and from that small p we can find out 540 upon 4000, it means 0.135. Capital P, which is population proportions of the COVID-19 patients rate, is 0.15, as we have already given 15%, and capital Q 1 minus P, so 0.85. Now null hypothesis. So null hypothesis P equal to 0.15, P equal to P0, 0.15. Okay, that is the hospital is efficient. Okay, and alternative hypothesis, if P less than 0.15, then uh, hospital is not efficient. So here level of significance we have given 1%. Now see, here we have given 1% level of significance. So statistic first we calculate small p minus capital P upon under root capital PQ by n, and here we get z is equal to minus 2.6567. So we can find out mod z, and now here critical value you have to find out 8.01, and 8.01 we get absolute value which is 2.33. And if we compare with this over value of z, then mod z, we can say that this mod z, which is greater than absolute value of z 0.01, that is null hypothesis, is rejected at 1% level of significance. Okay, this is the hospital is not efficient. Hospital is not efficient. Okay, so the same process whatever we have done in previous examples, same way we have find out the conclusion here. Okay, so find out small p, capital Q, then we have set null hypothesis, alternative hypothesis, level of significance, find out the test of statistics, then value, critical value, as we have given here 1%. So at 1% we get 2.33, and now we have compared both this, and from that we get mod z greater than absolute value of z 0.01. So null hypothesis is rejected at 1% level of significance. Okay, so now we move on next example. Example number 5. In a big city, 325 men out of 600 were found to be a smoker. Okay, so we have taken here sample of 600 people, in which out of 600, 325 men were found to be a smoker. Does this information support the conclusion that the majority of men in the city are smoker? Now, majority of men in the city are smoker, it means which is greater than 50%. If greater than 50%, then we can say that the majority of men in the city which are smoker. And here we haven't given a level of significance. If we haven't given a level of significance, so by default we consider at 5% level of significance. So first of all, sample we have given n is equal to 600. So small p we can find out 325 upon 600 is equal to 0.542, and capital P, which is 0.5, as we can say that here we have said that the majority of men in the city are smoker. So 0.5, it means if 50% which are a smoker, then which is not a majority, more than 50%, then we can say that the majority of a person which are smoker. So capital P is 0.5. Okay, we have said here capital P is equal to small, capital is equal to 0.5. Now what we can say about capital Q? Capital Q is 1 minus P, and which is also we get 0.5. Now null hypothesis. So capital P is equal to P0, and P0 we have right here 0.5. That is the proportion of smoker in the city is 50%. Okay, 50%, it means which is not a majority. Okay, we always set null hypothesis as a rejections of whatever we have asked. So here we have to ask conclusion that majority of men in the city are smoker. So we have set the null hypothesis 0.5. The proportion of smoker is 50%. It means the majority of men which are not a smoker. Now, what we get alternative hypothesis if p greater than 0.5, so more than 50% people which are smoker in a city, then we can say that this is a complementary of a null hypothesis. It means a alternative hypothesis. Now, p greater than 0.5, it means this is the right tail test. Now, level of significance, so we haven't given, so by default consider it 5%, so 0.05. And test statistics, again z equal to, we have a formula, small p minus capital P upon under root capital PQ by n. So after calculating all this, we get 2.06. Okay, so mod z is equal to 2.06. Now we have to find out the critical value, and at z equal to 0.05, which I get 1.645. Okay, so which is positive, so need not to be take the absolute value here. If we take the absolute value, then also we get the positive. So 1.645 critical value of z at 0.05. Now if we compare with this mod z, then we can see that this mod z which is greater than z at 0.05. So what we can say, this null hypothesis is rejected at 5% level of significance. It means the proportion of smoker in the city is greater than 50%. So majority of men in the city are smoker. Okay, is it clear? Is it clear for everyone? Is it clear? Reply in chat box. Anyone doubt? Then you can ask. Okay. In this example, we haven't given level of significance. Also, we haven't given like capital P, but we can conclude that from the majority of men. Now, majority, it means more than 50%. Okay, fine. Part have clear. Fine. What about others? Okay. So now we can move for the next example. Okay, fine. Example number 6. In a random sample of 160 workers exposed to a certain amount of radiation, okay, 24 experience some ill effect. Okay, 24. So out of 160, 24 experience some ill effect. Construct a 95% confidence interval for the corresponding to percentage. So here we haven't said to find the test the hypothesis. Here we have said that construct a 95% confidence interval, and I have already give you a note. If you don't remember, I show you that this note here. In note we have already given you the this 95% confidence limit, then small p plus or minus 1.96 under root capital PQ upon n. And if you have don't know capital P and Q, then you can use small p and small q. So this formula you require to calculate this example. Okay. Okay, so here we have to construct for a 95% confidence interval for the corresponding to percentage, and n we have given 160, and small p we can find out 24 upon 160, it means 0.15. So small p we can find out small q, 1 minus p is equal to 0.85. As we know that whenever we haven't given capital P and capital Q, you can use small p and small q to be construct a confidence interval, and here for we are to construct for 95%. So for 95% level of significance, confidence interval is p minus 1.96 under root small p small q upon n, and e plus 1.96 under root small p small q upon n. So now you already know this small p, small q, and n. Okay, so you can put this value in this interval and you get the confidence interval at the 95%. So if we put this small p 0.15 minus 1.96 under root small p is 0.15, small q is 0.85 upon 160, and now instead of minus here we have plus, and all other quantity is same as. Okay, so here 0.15 plus 1.96 under root 0.15, 0.85 upon 160. So but now you have to calculate this and you get the interval, that's all. Okay, so this is the 95% confident interval corresponding to percentage here, whatever we have given. Is it clear? So here we haven't said to check the test the hypothesis. Okay. And if you say that for 99%, then according to that, here you get some change. Instead of 1.96, you get some other value for 99%, 2.33, I think so, and which we have already note down. I have already given in a slide. So you have to remember this formula. Okay, P for a 95%, P minus 1.96 under root P cube by n, and P plus 1.96 under root P cube by n. And if you have given capital N P and capital Q, then instead of small p and small q, you have to use capital P and capital Q. Okay. So now, here we have completed this uh, for a single proportion, test of significance for a single proportion in a large sample test. Okay. Now we are moving for test of significance for a difference of proportions for a large sample. Okay. So here instead of one proportions, we have given two different proportions P1 and P2 for a sample proportions in a large sample test, and which you have a size n1 and n2. So more than one sample you have given. Here you have given a two sample, and for that you have given a proportion P1 and P2. Okay, and drawn from the two populations having proportions P1 and P2. So here instead of one populations we have given two different populations, and from that you have taken sample in sample for that sample size of n1 and n2, and which have a proportion small p1 and small p2. Okay, so for that now again working rule, first of all we have to set a null hypothesis. H0 is equal to capital P1 equal to capital P2. It means there is no significant difference in two population proportion capital P1 and P2. This is our null hypothesis. Okay, and alternative hypothesis is P1 not equal to P2, or P1 greater than P2, or P1 less than P2. So alternative hypothesis, it might be two-tail test or one-tail test. Once we set the alternative hypothesis, now level of significance, which is over alpha, whatever we have given in example. Okay, and then test statistic. So here there is two cases for a test statistic. First, when population proportion capital P1 and capital P2 are known. If capital P1 and capital P2 are known, then for a test statistic, your formula is Z is equal to capital P1 minus capital P2 upon under root capital P1 into capital P1 upon N1 plus capital P2 into capital P2 upon N2. So you have to remember this formula. Okay. So first of all, in example, if you have given population proportion capital P1, capital P2, then for a Z statistic, you have to use this formula Z equal to capital P1 minus capital P2 upon under root capital P1 upon N1 plus capital P2 upon N2. Now the second case, when population proportion P1 and P2 are not known, but sample proportions you know, small p1 and small p2 are known, and we have two methods to estimating capital P1 and capital P2, small sample proportions. Now to estimate capital P1 and capital P2, we have two method here. First method of substitutions. In this method, sample proportion P1 and P2 are substituted for capital P1 and capital P2. So whatever we have in our earlier formula, we have here capital P1, capital P2, but now we have capital P1 and capital P2. We are not known, but we have given small p1 and small p2. So what we do, we substitute instead of capital P1 and capital P2, small p1 and small p2. So small p1 minus small p2 under root small p1 q1 upon n1 plus small p2 q2 upon n2. So this is the first method of substitution. Whenever you have not given population proportion capital P1 and P2, and you have given a sample proportion small p1 and small p2 for two different populations. Okay. Now another method is method of pooling. The method of pooling, estimate value of two proportions is obtained by pooling the two sample proportions p1 and p2 into a single proportion small p. Okay. So pooling, it means small p we can find out by using this small p1 and small p2. Like we have already given n1 p1 and n2 p2, so n1 p1 plus n2 p2 upon n1 plus n2. And first we find out the small p. Once we get small p, now we have to use this formula z equal to p1 minus p2 upon under root p into q in bracket 1 upon n1 plus 1 upon n2. See, in previous one we used p1 into p1 upon n1 plus p2 into q2 upon n2. Now instead of this p1 and p2, what we have do, we have find out small p. How we have find out small p? We have write n1 p1 plus n2 p2 upon n1 plus n2. So by using this, and all this data you already have given in example. So by using this, you can find out small p, and then z is equal to p1 minus p2 upon small p into q into under root 1 upon n1 plus n2. So these two methods, whenever we haven't given capital P1 and capital P2, but we have given small p1 and small p2. Now critical value z alpha of z, which is given of a significance. Whatever alpha we have given, according to that we get the value of z alpha. Then we have to compare with mod z, whatever statistic we have find out. If mod z less than z alpha, then we know that the null hypothesis is accepted. And if mod z greater than z alpha, then null hypothesis is rejected. And now again here, if mod z greater than 3, then automatically null hypothesis is rejected for any level of significance. And second thing, confidence interval. Confidence interval 95% is here. Now we have two samples, so instead of p, we have now here p1 minus p2 plus or minus 1.96 under root capital P1 Q1 upon N1 plus capital P2 Q2 upon N2. And for 99%, instead of 1.96, you have 2.58. So P1 minus P2 plus or minus 2.58 under root P1 Q1 upon N1 plus P2 Q2 upon N1. And again here, if you have a not P1, capital P1 and P2, then you can use small p1, small p2, and small q1 and small q2. Okay. Now we discuss the example, or if you have given two different populations, and for that you have given a sample proportions or a population proportion. So here a random sample of 500 men and 600 women were asked whether they would like to have a flyover near their residence. Okay, so we have two different samples, 400 men and 600 women. Now 200 men and 325 women were in favor of the proposal. It means they want a flyover near their residence. Now we have to say that test the hypothesis that the proportion of men and women in favor of the proposal are same at the 5 level of significance. Okay, so we have to test the proportion of men and women in the favor of proposal, and at the level of 5% of significance are same. Okay, so both have a same proportion. There is no difference between the favor of men and women. Okay, to have a flyover in near their residence. So first of all, we have given N1 is equal to 400 and N2 is equal to 600. And so first proportions, out of 400, 200 men which are in the favor of the proposal. So small p1, okay, which I get 200 upon 400, which is 0.5, and small p2, which is 325 upon 600. It's 600. Second sample we have 600, okay, and 325 women which are in the favor of a proposal. So small p2, which we get 0.541. So we can calculate here small p is n1 p1 plus n2 p2 upon n1 plus n2, and so I get 0.525. Here I have used method of pooling. Okay, so once we get small p, find out small q, 1 minus small p, and so this is 0.475. Okay, now we have to set the null hypothesis. It means there is no difference between population proportion capital P1 and P2. That is, there is no significant difference in proportions of men and women in favor of proposal. Okay, so both are equal favor in the proposal. Okay, it is, and which we are saying for all populations from the sample. Okay, this which we have set the null hypothesis. Okay, now alternative hypothesis, it means the both have a different opinion, P1 and P2. So it means men and women which have a different opinion in the favor of a proposal that lie over near to their residence. Okay, so here we have a two-tailed test, P1 not equal to P2. Now level of significance, alpha is equal to 0.05. Now test of statistics is Z is equal to P1 minus P2 upon under root PQ into 1 upon N1 plus 1 upon N2. Okay, P and Q which we have already find out, P1 and P2 we have already find out here, N1 and N2 we have given. So all this value we have put in this formula, and this formula you have to remember. Okay, so once we put all this value, what I get, Z is equal to minus 1.28. So what we write, mod Z is equal to 1.28. Once we get this test statistics, now we require to find out the critical value at 0.5 level of significance. So absolute value of Z at 0.05 is, we know that, which is 1.96. Now we have to compare these two values, is mod Z and mod Z.05. So you can see that this mod Z which is less than mod Z at 0.05. So what we can make a decision here, that the null hypothesis is accepted at high level of percent of significance. It means there is no significance of opinion between man and woman in the favor of the proposal. Is it clear for everyone? Is it clear? Is it clear for everyone? Reply in chat box. Now here we have two different populations, and we have given two different sample for two different population. Like here as a populations, we can say that the one first populations is a number of men, and second one is number of women. Okay, and for that we have given a sample 400 and 600, and out of them we have find out this 200 men and 325 women which are in the favor of proposal. Okay, so Nancy has clear. What about others? Is it clear for everyone? Okay. Fine. So now we can move to next example. Okay. So now second next example. Before an increase excise duty on tea, 800 people out of the sample of 1000 were consumer of a tea. Okay. And after increase the excise duty, 800 people were consumers of tea in a sample of 1200%. Okay, so two different sample of 100 consumer of tea people and 1200 persons which we have given. So before it increase the excise duty, 800 people out of 100 which is a consumer of tea, and after increasing the excise duty, 800 out of 1000 and 1200 student, sorry, 1000 and 1200% out of 800 which are the consumer of a tree tea. So find whether there is a significant difference in the consumptions of tea after the increase in a duty. So we have to say that find there is a significance decrease or significance decrease in the consumptions of tea after the increase in the duty. So here we haven't given a level of significance. So by default we consider high level of significance. Okay, high% level of a significance. So first of all, what we have given N1 and N2. So N1 is 100, sorry 1000, and N2 is 1200. And what we get small p1 and small p2. So out of 1800 people which is a consumer of a tea, so I get zero point 0.8, and p2 is out of 1200 800 which are the consumer. Sorry, here not a man. Okay, instead of man and woman we have to write here a people. So here is the correction, not man and woman. Here we have people. Okay, not man and woman here. So of people, which P1 is zero point 0.8 and P2 is 0.67. Now small p, N1 P1 plus N2 P2 upon N1 plus N2. So 1000 into zero point 0.8 plus 12,000 into 0.67 upon 1000 plus 1200, and small p which I get here 0.73. Once we get small p, we can find out small p, 1 minus small p, so 0.27. Now null hypothesis. So p1 equal to p2, capital P1 equal to p2, so which we are say for whole populations. Okay, here we have taken a sample. So for whole populations, P1 equal to P2, it means there is no significant decrease in the consumptions of tea after increase the excise duty. Okay, excise duty. So what we can say about the alternative hypothesis? It means there is P1 greater than P2. So after increased excise duty, there is a uh, the P1 which is it means here uh, 800 people out of 1000 is consumer of tea, and 800 out of 2000. So it means it's a decrease uh, of a decrease the consumptions of a tea, number of people or which consumption of tea which is decreased. It means P1 greater than P2. It means before the excise duty, okay, the number of consumptions are more than after increase the duty. So that's why here we have take P1 greater than P2. Okay, alternative hypothesis. Okay, we get this P1 greater than P2. As we have here no significant decrease in the consumption. If decrease in consumptions, it means before excise duty, number of people which are consumer of a tea are greater than after increase the excise duty. So I can set the alternate hypothesis as P1 greater than P2. And P1 greater than P2, it means it is a right tail test. Now level of significance by default we consider as 0.05, and test statistics Z, which is P1 minus P2 upon under root small p small q into 1 upon n1 plus 1 upon n2. So after putting all this value, I get z is equal to 6.84. Okay. So what we can say about mod z? Mod z is also 0.6.84. Now level of significance at 0.05. So for a right tail test, which is the 1.645. Now if we compare this mod z and z at 0.05, so directly you can say that this mod z, which is greater than z.05, and if greater than, then we know that the null hypothesis is rejected at 5% level of significance. So there is a significance decrease in consumption of tea after increasing in a duty, okay, in exercise duty. Is it clear for everyone? Okay, after increase the duty, so before the increase the duty, we have 800 out of 1000 consumer, but after increase the duty, we have 800 out of 1200%, 800 which are the consumer of it. So definitely, which is a from the test by, even from the data we can directly say, but we have used the test of here, and then after test we get this mod z greater than at z.05. So we can say that this null hypothesis is rejected at 5% level of significance. Okay. Now example number 9. In two large populations, there are 30% and 25% fair hired people respectively. Okay. So there are some fair hired people which are from the two different large populations. We have 30% and 25% which are fair hired people in some company. Okay. Is this difference likely to be hidden in sample of 1200 and 900 respectively from two populations? So here we have given capital P1 and capital P2. In sample we have given N1 and N2. This is 1200 and 900 respectively from two different populations. What we have said is this difference is like to be hidden, okay, in a sample. So first N1 and N2 and capital P1, and once we have capital P1 we can find out capital Q1, capital P2 which we have given 0.25. So you can also find out capital Q2, as we have to require this capital Q1 and capital Q2 to calculate test statistic. Okay. Now null hypothesis which we set as P1 equal to P2. That is the difference in the population proportions is likely to be hidden in a sampling. Okay. In a, so this is our null hypothesis P1 equal to P2. So what we can say about alternative? That is P1 not equal to P2. It means the difference in population proportions is not likely to be hidden in a sampling. Level of significance is alpha is equal to 0.05. Now statistic. So here in this example, instead of small p1 and small p2, we have given capital P1 and capital P2, because here we have from the data we have given, say, from the large populations they have said that 30% and 25% fair hired people. Okay, and in previous example we have given a small p1 and small p2. Okay, but instead of that here we have given capital P1 and capital P2. So in a Z statistics here, test statistics, we have Z is equal to capital P1 minus capital P2 upon under root capital P1 Q1 upon N1 plus capital P2 Q2 upon N2 instead of small p1 and small p2. Okay. So what we get Z here? Z is equal to 2.56. So what we can say about mod Z? Mod Z is also 2.56. Now level of significance, which we haven't given. So by default, we consider is 0.5. So we can find out the critical value z at 0.05, and for 210 test we have which is 1.96. 1.96. So this mod z, which is greater than absolute value of z at 0.05, so we can say that this null hypothesis is rejected at 5% level of significance. So what it means, the difference in population proportions is not likely to be hidden in sampling. Okay, so same way, but there is only one difference here. Instead of small p1 and small p2, we have given capital P1 and capital P2. Okay, so now sample number 10. So a random sample of 300 shoppers at a supermarket include 204 who regularly uses cents of coupons. Now, in another sample of 500 shoppers at a supermarket include 75 who regularly uses a cent of coupon. Proportion. Questions. So here 95% of confidence limit we have to say. Here we have not said to test the testing, but we have to say that find out the confidence limit. And we have already note down this, that what is the formula for to find out the confidence limit. And what we have given here n1 is equal to 300 and n2 is equal to 500. Okay, so n1 and n2 we have given. Now we can find out small p1. So small p1, which is from the sample, we have given 204 people who regularly use cent of uh, use the this coupon 20. So what I get small p1 is 0.068. Okay. Now from once we get small p1, why we can say small p1, because we have take a sample. Okay, from the sample we get this. In previous example, from the population directly we have given. Small q1, which is 0.32, and small p2, which I get 75 as out of 500 shoppers in another sample, that 75 which uses regularly the cent of coupon. So out of 500, 75 using the cent of coupon. So small p2, which I get 0.15. So you can find out small q2. Once we, so here now we have n1, n2, small p1, small q1, small p2, small q2. So we can consider this small p, or here we call it standard error. P1 q1 upon n1 plus p2 q2 upon n2, and which I get 0.051. Now confidence limit of the difference in populations, which is now we have a formula for p1 minus p2 minus 1.96 under root p1 q1 upon n1 plus p2 q2 upon n2. Formula. Whenever you have it for two different ones, you put all this value. What you get? It is 0.469. 0.469 and 0.591. Okay, so this is the confidence limit. Percent. Now here we are stopping.